I'm Suresh, working as an assistant professor in Department of Civil Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. So in today's class, let us discuss about setting out of curves. Generally, any straight line, when deviates from its path, it results a curve. There are various methods proposed in surveying to design or to trace a curve. So here in today's class, we discuss about setting out of a curve by radial offsets from tangent. So curves are very common in transportation engineering. So how to design a curve, let us discuss in this class. So any straight line, when deviates from its path, it results a curve. Based upon the deviation, a curve can be a right-hand curve or a left-hand curve. Now, there are various methods involved to design a curve based upon the profile of land and situations. So we have vertical curves as well as we have horizontal curves. In today's class, let us discuss a method how to design a horizontal curve. So the apparatus what we require are very simple and easy. So in today's class, the apparatus which we require are a measuring chain with a length of 20 meter or 30 meter as per the availability, and pegs, and we require ranging rods. So these are the basic apparatus which we use in today's experiment. Now let us see the procedure. So before going to the procedure, we have various methods like setting out of curve using perpendicular offset method, radial offset method, and offsets from long chord method, 2 theodolite ranking method, and rankings 1 theodolite method. Let us discuss a very simple and easy method in today's class. Now my method is perpendicular offsets, radial offsets from tangent. Here OA is a tangent and OB is a straight line, and we are getting a curve here. So what I do is I measure the length of the tangent with the help of a 20 meter chain as shown here. I want to draw a curve along the horizontal direction. So from point O to A, I measure distance. So my first interval is 20 meters. So it's coming up to a point P. Now I want to find the length of an OX as shown in the figure. So how to find OX? And here its radius is common. Okay, we have a common radius throughout. So OQ and OX, sorry, Q2 in this point is the same radius throughout. So now, if I want to find the length of the offsets, I am applying the principle of Pythagoras theorem. So it's form a triangle POQ. So we know that triangle POQ is there. So QP square is equal to PO square plus QO square. So we know the principle. So I am applying the principle here. So PQ square is equal to square of the hypotenuse is equal to sum of the squares of the other sides. So PQ is equal to root over OP square plus OQ square. So here OP is X. So X is a 20 meter interval or it may be 5 meter interval. So X square plus R square. Here PQ is equal to R plus OX. Here OX is the unknown interval. So in this experiment, we are going to find the radial offsets at an interval of 20 meter. Suppose it is 40 meter, again you get OX2 here. If it is 60 meter, you get OX3 here. Like that you form a curve along the path. Now here for first interval of 20 meter, I want to find the value of OX. Now how to find OX? So here PQ is equal to root over PO plus OQ. So here PQ is nothing but R plus OX. R plus OX is equal to under root of X square plus R square as shown in the figure. So from here I want OX. OX is equal to under root of X square plus R square minus R. So OX is the radial offset distance. It can be measured with the help of a chain as shown here. So OX is some X meters and OX2, OX3, OX4. As the length increasing, the OX value also increases along the curve. So if the first interval of OX is 2 meter and second interval may be more than 2 meter and less than 4 meter. So like that we have some fundamental formulas to calculate the offsets in your curve setting. So this is one of the formula. This is called radial offset method. If offset is taken perpendicular, it is called perpendicular offset method. Here we have a formula that is OX is equal to R minus root over X square minus R square. Here also we apply the same principle of Pythagoras theorem, but here it is not hypotenuse, it is from side. Apart from this, we have ranking third theorem method. So here the interior angles are opposite and equal. So we apply the principle. That is, interior angles are opposite and equal. So here from left hand side, if you make an angle of theta 1, from right hand side again the theta 1 is taken from the right hand side using the device called your theodolite. So this is one of the experiment, and the result of the experiment is we have to trace out the interval of OX, that is radial offset interval, for every 20 meter, 40 meter, 60 meter up to the length of the stretch. So here we have some obstacle, so we are deleting the curve here. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.